simplify 1 divided by a plus 1 divided by b, divide by 1 divided by a to the third power plus 1 divided by b to the third power. As you see, this is a complex rational expression. It's a complex because its numerator is a rational expression, 1 divided by a plus 1 divided by b, and similarly, the denominator is also a rational expression. 1 divided by a to the third is a fraction, plus 1 divided by b to the third is also a fraction. So together, the top is a rational expression, the bottom is a rational expression. Remember that a complex rational expression is an expression that has at least one, the numerator, or the denominator is a rational expression. For this case, we have both. Alright, to simplify this complex rational expression, we need to find the LCM, the least common multiple of the denominator in the top part and the denominators of the bottom part. So let's see the top denominator, okay? Denominator on top we have, which is a and b, okay, and denominators at the bottom is a to the third and b to the third. We need to find the LCM, least common multiple of the top and bottom, okay, up tops and bottom. Remember, the LCM include all the factors of a, b, a to the third, b to the third. It must be an expression that contains a to the third, b to the third, a, b. So you know that a to the third include a, b to the third includes b. So LCM must be a to the third times b to the third, okay? So LCM is a to the third, b to the third. If you have question with LCM, please review the concept of LCM, least common multiple. Now we know LCM, we can multiply the LCM, divide by LCM to the rational, so to the complex rational expression here, the original expression. So let me rewriting the original complex rational expression. So 1 divided by a plus 1 divided by b, divide by 1 divided by a to the third plus 1 divided by b to the third, and multiply by the LCM on top and bottom. Okay. Now I'll replace the values a to the third, b to the third for the LCM. So multiply by a to the third, b to the third for the LCM. If you want, you can put the parentheses here just to make it easier to follow. Now, the next step is distribute the LCM, okay, the whole thing, to every term on top, and the LCM to every term at the bottom. With the arrow here so you see it direction. So multiply this out, I would get 1 over 8 times a to the third, b to the third, okay, and plus a to the third, b to the third times 1 over b. We got 1 over b times a to the third, b to the third, divide by, now LCM a to the third, b to the third, multiplied by the first term at the bottom. We have 1 divided by a to the third times a to the third, b to the third, the LCM. And then next, we multiply the LCM to the second term at the bottom. So plus 1 divided by b to the third times a to the third times b to the third. Okay, to take this, multiply this, we get this part. Now, you need to simplify as much as possible. Let me continue here. So here I got from here. So to continue from here, I would get now, and you see, this is simplified, so make sure you simplify any common term, any similar term that you see. So a and a on top divided by a at the bottom. Let me use different colors so you see it better. So a on top and a at the bottom. We would left with a squared. Okay, a to the third divided by a is a squared times b to the third. Okay, and then plus, I'm still working on the top part right here. Now we have b at the bottom and b on top needs to cancel out. B to the third divided by b is b squared. So I'm left with b squared. But don't forget the a to the third. I usually put them in the alphabetical order. So a to the third times b squared. So we just simplified the top part. Now focus on the bottom. Okay, so for the bottom we have, let's see, a on top divided by a at the bottom. So a to the third divided by a to the third. We actually cancel out completely. We're left with 1 times b to the third. Okay, they are same base or similar. Variable a to the third, when you cancel out, you become 1 plus, go here. Now, the bottom b to the third divided by the top b to the third, so they cancel out completely. So you're left with 1 times a to the third. Okay, so let me move this here. So now I got a squared b to the third plus a to the third b squared divided by 1 times b to the third plus a to the third plus 1. Simplify further, we would get a squared b to the third plus a to the third b squared divided by 1 times b to the third is itself b to the third plus a to the third plus 1 is a to the third. Okay, let me make this more clear. So this is the third power here. Alright, so we're almost there. So make sure, because when they say simplify, make sure you simplify everything out completely. Now look at the top part. What is the maximum variable you can factor out? Now look at the a squared and a to the third. You know that you can factor out a squared. How about b? B to the third and b squared. You know that you can factor out b squared on the top. Now, a squared times b squared times what? Is a squared times b to the third. Got to be b. Okay, you can double check. A squared b squared times b is a squared b to the third. Alright, how about this part right here? A squared b squared times what? Will become a to the third times b squared. Got to be plus a. Okay, let's double check. A squared b squared times a is a to the third b squared. So that's the factor for the top part. On the bottom, b to the third plus a to the third. Alright, this one is a bit interesting. we learned how to factor this using the formula. So let's write out the formula we got. So when you have the formula a cubed plus b cubed, so this is the formula, okay, is equal to a plus b times a squared minus ab plus b squared. Okay, so when you factor the sum of two cubes, you get a plus b times a squared minus ab plus b squared. So I'm applying this formula here. I would get b plus a times b squared minus b times a plus a squared. Okay, so we just factor out the sum of two cubes using this formula. Remember, the capital A is playing the role of the small b, and capital B is playing the role of small a. Okay, or if I rewrite this formula to a better form, let's say I can make it m plus k cubed and cubed here, if it helps you. So basically same formula, we just use different letter. So m cubed plus k cubed, factor out, you would get m plus k times m squared minus mk plus k squared. Okay, so m is the small b right here, and k is the small a right here. Using this formula, m plus k, meaning b plus a, and then m squared minus mk plus k squared, come from b squared minus ba plus a squared. Okay, they are same formula, just different letter. Alright, so we got to this point. Now look at the top and bottom. See if you can simplify anything as much as possible. And you see, it turns out b plus a and b plus a at the bottom can be cancelled out. You're left with 1 on top and bottom. So 1 times a squared b squared is a squared b squared divided by 1 time the rest is b squared minus ba plus a squared. Okay, so look at the top and the bottom, see if you can factor this any further, and look like this is it. You cannot factor any further, so you know that you're done with simplifying this complex rational expression. So to show you this completely, this is how we simplify this. First, we multiply LCM on top and bottom. Then we distribute the LCM on top and the bottom. We got this part. Then simplify. We get this over here. Okay. And then simplify as much as possible. We got to this point where we have the sum of two cubes. We will use this formula to factor out the sum of two cubes. To factor this out, turns out we have common factor on top and bottom, b plus a. Cancel these two out. We're left with the answer a squared times b squared divided by b squared minus ba plus a squared. So this is how you solve or simplify this rational complex expression.